This is solving quadratic inequalities part 2. Notice this inequality right here is not in descending order. We don't have a 0 on the right side. So this is important stuff right here. The equation must be in descending order, and we want it to be on the left side, and we want 0 to be on the right side. So this is not in the right form. Very easy to get it in the right form. All we need to do is subtract 6 from both sides, which just moves 6 to the other side. So there's my inequality, which fits the criteria of my inequalities on the left side in descending order, and we have 0 on the right side. One other thing, we're going to want this to be a positive x squared. We want this to be positive x squared, which in this case it is. So we continue with what we did in the first video. We're going to write it as an equation instead, and then we'll factor this and solve it. It factors as x plus 6 times x minus 1. Here's your simple solving, and we have these points, negative 6 and 1, to put on the number line. Here's our x plus 6 right there, x minus 1 right there, and then this is for the product. Now, test points here, I need to pick something to the left of negative 6, which would be something like negative 7. Negative 7 plus 6 is a negative 1, which is a negative value. Negative 7 minus 1 is negative 8, which is a negative value. A negative times a negative is a positive. Pick a number between negative 6 and 1, which is 0. 0 plus 6 is a positive number. 0 minus 1 is a negative number. And the product of a positive times a negative is a negative. Pick something to the right of 1, like 2. 2 plus 6 is 8, which is positive. 2 minus 1 is positive. A positive times a positive is a positive. Because we are looking for our values to be less than or equal to 0, that means we are looking for the negative values. Those are the numbers that are less than 0. So where our graph has a negative in the bottom row is right here. So that says we're going to shade between the negative 6 and the 1. The only thing I have to decide on is what symbol to put at my endpoints. Because this was less than or equal to, we're going to go with the square bracket. And that is our graph of the solution of that inequality. We also want to write it using interval notation. This is clearly the interval from negative 6 to 1 with the square bracket because that's what we used on the graph. Here's another one that's not in the right form. I need to do something to get it in the right form. And the first thing I would do is add x to both sides. I'm going to squeeze it in the middle here. So now I have negative 2x squared plus x plus 3 is greater than 0. So kind of good news and bad news. I have everything on the left side. I have 0 on the right side. This is in descending order, but I don't want that to be negative. Very easy for me to change it, and that is just divide everything by negative 1. Everything by negative 1. That means both sides by negative 1. And you should remember when you divide an inequality by a negative, that makes that inequality sign change. Of course, 0 divided by anything is still 0. And now this stuff over here is positive 2x squared minus x minus 3. Here's our equation. We need to factor that. It factors as 2x minus 3 times x plus 1. Set each of those equal to 0 and solve. This gives me x equals 3 halves because I'll add 3 to both sides and then divide by 2. But because we're putting this on a number line, I'd rather think of it as mixed number. And then on the number line, I wrote it as a decimal. Let's choose our test points. Something to the left of negative 1 would be like negative 2. Plug negative 2 in here. 2 times negative 2 is negative 4. Minus 3 is negative 7, so that's a negative. Negative 2 plus 1 is negative 1, which is a negative. A negative times a negative is a positive. Pick something between negative 1 and 1.5. I like to pick 0 because that arithmetic's so easy. 2 times 0 is 0. Minus 3 is negative 3. 0 plus 1 is a positive 1. The product of a negative times a positive is a negative. Something to the right of 1.5, like maybe 3. 2 times 3 is 6. Minus 3 is a positive 3. 3 plus 1 is a positive 4. A positive times a positive is a positive. Go back to this equation where we had it in the right form, not the original, where we've got it in the correct form. This is less than. The values that are less than 0 are the negative values, so that we want to shade anywhere we see the minus down here on our lowest row. Well, where the minus sign is in this region, which is between negative 1 and 1.5. Last thing to decide is what kind of symbol goes here. Because this is plain old less, I get to use the curved parentheses, which leads me directly to my interval notation, the same curved parentheses from that endpoint of -1 to that endpoint of 1.5. Now, I don't know if you've noticed the way we've been shading, but there is a shortcut that works for quadratic inequalities. Later on, we're going to talk about polynomial inequalities, like maybe x cubed or x to the fourth. But as long as this is x squared, there is a shortcut. Now, this works when our inequality is in this form. Ax squared plus bx plus c is whatever inequality sign and then 0. Any inequality sign could be here. The less than, the greater than, it doesn't matter. Of course, these don't really have to be pluses. It could be plus and negative b, etc. So here's the deal. If the function is on the left side, like this, and the coefficient in front of x squared is positive, and 0 is on the right side, then we can find our points from solving like we did before, and we will shade automatically based on that inequality sign. Because that is less than or less than or equal to, we shade between. When the sign is greater than or equal to, we shade the outer ends. Now, I have the different symbols here just to indicate when it was the greater than or equal to, that's when we used the square bracket. When it was just plain old greater, we used the curved parentheses. Same thing on this one. When it was less than or equal to, we used the square brackets. When it was just plain old less, we used the curved parentheses. So you can use that shortcut, but you have got to have this stuff here. You can't have a negative in front of x squared. You can't have some other number over here. It needs to be in descending order like this. And then you get to just use those appropriate shadings based on that inequality sign. And that just saves you the time of having to do all the test points. But I'm going to say it again. These shortcuts only work if it is x squared. The next video will tackle x cubed, and you can't use these shortcuts for that. Let's do a couple of these using the shortcut. Here's the inequality. We're just going to go straight to factoring it and putting an equals 0 right here. When you factor this and then solve, you should be able to solve this in your head. Here's the two numbers you have. They're going to go on the number line, -3, -2. I don't have to build the big box. I don't have to pick any test points. All I have to look at is my original sign here, when this is in the correct form, is less than or equal to. Less than is where we shade between. Because it's less than or equal to, I go with the square brackets, and that's as tough as this is. Another example, similar problem, x squared minus 5x minus 6. It factors differently because of the minus. But we get these solutions, 6 and -1. I'm going to place those on the number line. Because this is greater than, then I know from my shortcut that greater than I'm going to shade to the outside from those endpoints. Because this is plain old greater, we're using the curved parenthesis. Now there are a couple strange things that can happen with these, and it's this idea right here. If we take something like this, and we factor it equal to 0, I only get one solution because this is a perfect square. I get one solution. So I only have one place on the number line. Can I still think about using my shortcut? Sure. This is greater than, so greater than we shade to the outside. So this would get shaded out this way. This would get shaded this way. But we have to think about what to do right here at -2. This says plain old greater. That means -2 itself is not included in the solution set. So I need to go back to the old open circle idea and put a hole right there on -2. That means every point is going to work in this original inequality except -2. Would it make any difference had this been greater than or equal to? Yeah, the only difference would be, instead of it being an open circle here, it would be a colored in circle, meaning every point on the number line, or all real numbers, would make this inequality true. Now the other similar strange happening is right here. Same exact problem, I just changed the inequality sign to be less than. I still just get one solution of -2. Now if you think about using the shortcut said shade between those two numbers. Well, I can't shade between one number. If you think about your test points, if you pick a point over here, like -3, and plug it in up here, we're going to have a negative times a negative is a positive. If you pick a number to the right of -2, like 0, and put 0 into each of these, we're going to get a positive. We're looking for a negative value. There is nowhere on this number line we're going to get a negative value, and that's why this would be considered empty set, no solution. If, however, it is less than or equal to, we do get one solution, and it's the point itself. So that only happens if you're dealing with your quadratic being a perfect square trinomial and you only get one point on the number line.